Hey everybody, I want to welcome you to the next edition of the BobCAD webinar series. Today's topic is Intro to MillTurn C-Axis. In today's webinar, you'll gain a basic understanding for C-Axis milling and drilling. You'll also learn how to mount tools and use adapters. Now, as you know, my name is DePoalo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at DePoalo, or you can also search BobCAD After Dark, hashtag BobCAD After Dark. So what am I going to learn today? Well, we're going to talk about job setup, where your part is, how to set up the job, mounting tools and adapters, and then we're going to review face milling and drilling, OD milling and drilling. Okay, so if you want to learn about these types of things for MillTurn, then this is the webinar for you. Okay, job setup, we're going to talk about machine choice, the stock wizard and origin. The BobCAD MillTurn software does support 2 through 5 axis. It does support Y. It does support sub-spindles. In today's example, we're going to look at a single turret, single spindle machine. We're going to go through the stock wizard, and we're also going to set up the origin. Now, we're going to talk about the tool crib or the turret, station and adapters, loose and mounted tools, and shift and orientation. Okay, so we're going to go through an example where we're going to load tools and load adapters and move things around. Now, we're also going to look at face milling and drilling. So we're going to drill, pocket, profiles, and chamfer. We're going to do that on the face of the part. And then we're also going to do OD milling and drilling. So we're going to drill, profiles, and pockets, and also chamfering. Okay. Now, as always, with BobCAD, you can expect fewer steps, better cuts, and more profit. And I want to thank everybody for getting started with us here today. Now, give me a second to get the software up. And while you're waiting for that, if you can go ahead and just announce who you are, your name in the question section, who you are and where you're from. I'd just like to get a good idea of everybody that I'm speaking with. Also, another thing that's really important for this and every webinar that I host, any questions that you have, there's a questions section in the GoToMeeting software or GoToWebinar software. Just write in any question that you have. Now, I'm the only one that's on the webinar, so I'll do my best to answer the questions as we go. If I'm unable to answer your question when you ask it, know that there will be a Q&A document that is sent out to you with the video recording of this webinar. Okay, so I want to thank Bob for coming out here today. We got Randy, Bob from Ernie, PA, David from Missouri, John from Michigan. Thank you so much for coming here today. Richard from Illinois. We have Netherlands here. We got Robert from California. Okay, Jesus from Houston, thank you so much. Chuck, we got Jeff from Jeff Calloway here. Thank you again so much for everybody coming. Larry from Tennessee. There's a lot of things to cover in today's webinar, and like I said, if you have any questions as we go, or anyone that you've struggled with or have thought about or just wasn't certain or unclear, please write it in the question area. At the same time, before we get started here, if you are a current MillTurn customer, just go ahead and write in the question area that the version of the software that you're running, and that you're a MillTurn customer. So I want to see how many people that are in today's webinar have already owned the software and what version they're running. At the same time, whether you're a customer or not, if you have a MillTurn machine, please write in the machine brand and controller that you're running so we understand what kind of machines you guys are using and what controller you're running. So if you can take a moment to do that, I would really appreciate it. Okay, so here we go. This is a sample part. This is the sample part you saw in the PowerPoint here, and this is the part that we're going to review today. There's a couple of different things that we're doing on here. The first thing that I really want to talk about is the CAD preparation. So when we look at this file here, one of the things that you're going to notice is I do have a number of layers already set up. You'll see I have my part model on a layer. I have some work holding. I have the part profile. You know, what I've done is I've in my CAD preparation stage, I took the time to kind of set up the part, creating all the wireframe or whatever else I might need before I go to programming the part, okay? So I definitely recommend you use this kind of workflow. It does make it much easier as you move down the line and are working through the part. Now, the other thing I want to talk about real quick is in the CAM tree over here, you know, the visibility of things. Whether you're a new user or an existing user, you do have the ability to blank and unblank the entire job. What that will do is hide everything on the screen so you don't see it, or you can turn it back on so you have blank, unblank, and this way you can turn things on and off that you don't want to see. Now, you could turn off the stock or you could turn on the stock. So again, this is just a way for you to isolate what you're looking at. You can turn everything off in the machine setup, you know, and then maybe we'll go to this face, mill, and drill group and we can unblank that. And this way we can look at just the tool paths that are in that particular group. Okay, so that's a very useful tool, and I do recommend that you utilize that. Now, you'll also notice on this job here, I do have 2 folders set up. You'll notice that I have the face, the turning cycles folder, and this has my face routine, and then it also has my OD turning, and then I also have a group or a folder here which has my face, mill, and drill, and all of those different operations. As a general workflow, folders or groups is a great way to organize your job. You can do it for completed cycles, separate out things that you've started, or you can also use it to separate out different things that you may be working on. Mark had a question, rotary table on a Bridgeport. There are some things here that carry over, Mark, but this is definitely a MillTurn presentation. What you'll find for 4-axis indexing and wrapping and rotary does match the MillTurn product, and I did just do a webinar on 4-axis standard just the other week, so I would recommend you watch that one. All right, now the other thing that we're looking at here, we have these all blanked out. You can go to any of these operations. You can right-click on the cycles and go to backplot. So this way you can display what that tool is doing without launching simulation. You can do this for the turning cycles, and you can also do it for the milling cycles. And essentially, when we're looking at the MillTurn package, it is just the milling and turning combined into one job tree, okay? All right, so the next thing I want to do from here is I want to get into simulation. As a MillTurn customer with the MillTurn product, you do get machine simulation. This is a standard that comes with the package, and I think it's one of the advantages of the MillTurn software is being able to visualize exactly what's going on in your job, okay? Actually, let me close this for just a second. Let me turn my work holding on here, and then let's turn this back on. Okay, so when we're looking at simulation, you know, there's a lot of different things that you're going to want to check or be able to visualize to make sure things really make sense, okay? There are some generic models that come with the software for your machines, or you can build your own machines. You can get these models from your machine tool dealer. You could have a third party build them, or you can build them yourself, okay? I definitely recommend using the machine simulation. It's going to really help things out. Now, the first thing that I really want to look at is the visibility, okay? You do have the ability to turn the tool path on and off, so you can display the tool path. You can turn the tools on and off. You can show them or hide them or make them transparent. You can do that with the workpiece as well, so you can show the workpiece or make it transparent or hide it, and you can do this with the stock too, okay? So if you're trying to view different aspects of your job, you can go to your visibility and you can turn these things on or off as necessary, okay? So we got visibility of the tool path, the tool, the workpiece, and the stock. Now the other thing, depending on how your machine is built up, you may have a housing around it. You know, there's things that you may or may not want to see while you're going through the simulation. If you double right click on one of the components, you can go to hide or make transparent of the machine components as well. So this way you can get rid of models that you may or may not want to see in order to help you see what's going on, okay? So again, that's a double right click. So if you go over any machine component and you do a double right click, you'll get some options here, so you can go to hide, and this way you can break it down to, you know, maybe the chuck and the turret, or whatever the case might be. All right, now in order to bring it back up, you can change your focus from workpiece. You can go back to machine, and then it will reset and bring everything back for you. Okay, so I think that's really important as well. Now, the next thing I want to talk about is collision checking, because one of the advantages of being in machine simulation is you're going to have collision checking. So I'm going to turn my axis control on here. Okay, I'm going to turn the visibility of my toolpath off. Okay, I'm going to drop my x-axis down. Okay, and then I'm going to take my z and I'm going to run it into my chuck and my workpiece here and my model, and you can see it turns red as it goes. Now I did adjust some of the limits so it won't go back and it won't go any further than 0 on the face of the chuck, which would be the 0. But this way you can see that collision checking is turned on. You can also check against, like if you have the housing here, if your tool is hanging out too much or something like that, you would also be able to have a collision checking group against that as well. And that's really important. If you had a subspindle or a turret or you know, any of the other machine components in there, you would be able to be able to see what's going on. There was a question that came in, MillTurn in one folder and mill drill in another folder. Can you get the operations in any order you desire? Mill cycle before turning completed. Yes, Russ. The folder just organizes the features in the tree. As far as the posting order, that's done with the machine posting, or the I can't think of the name of it off the top of my head, but I'll show you here in just a second, where you control the order in which things are posted, either by tool dominant, by feature dominant, etc. So that applies whether it's in a folder or not. Okay, so that's a little bit about the collision checking. Okay, so let me close that out. What I'll do is I'll open that up now, Russ. If we go to our MillTurn job and we go to machining order, the machining order is going to control the order in which the cycles are being posted in. Yeah, Randy called it. So that's right, machining order. So from here, this is going to list out all the different operations. You can post it by individual feature, and then it sorts it by the feature. You can post it by individual tool, and then it sorts it by the tool. So that's how that's handled for your machining order. Again, the folders just organize, just kind of group things together. So when you know, if I want to look at my face mill and drill, you know, I can blank or unblank that. I can do that in one shot versus having to do it in multiple, going through multiple features, okay? Or the other thing is if I want to turn that off, I can just click on one folder versus having to go through and click on all the individual items, okay? So from here, the next thing that I want to get into is just some of the posting samples, okay? So, you know, we have this job, actually, let me go back and simulate what's going on. Let me pull up simulation again. And just so we can kind of see what we're after to accomplish here today, and the type of cycles we're going to call up. All right, so let's close this out. All right. So what we're going to do, let me, I'm just going to go to workpiece focus here so we can kind of see what's going on. Let me hide my workpiece. You know, so I have a facing cycle here. The facing for 2-axis turning is the same for MillTurn. I have an OD cycle here where I turn down the profile. The next thing I do, I do a OD rough, OD finish. From here, you know, I'm going to just drill some holes on the face of the part. Okay. It is showing up red because my depth of the hole was deeper than what was modeled. The next thing that I have here, this is an open pocket, so I'm doing an open adaptive pocket on the face of the part. You could do a profile routine there as well, and I'm going to show both of them. Let's see here. This is probably like a finish on the face of the part as well. So we drilled, oh no, I did a circular pocket. Now I'm doing a profile around the, like to finish the wall. You know, I come back and break the edge. So this is all the face milling drilling. So I drilled some holes. I did an open pocket. I did a circular pocket on the you know, the bore in the center. I'm going to do some chamfering where I'm going to come back and break the edges here. And that's what I'm doing on the face. On the OD, I have these slots that I cut into it, so I do a wrapping group for those. And then I use some index systems to come in here and to cut these slots, and then I drill out some holes. Okay, so that's what we're looking at to do in this particular routine here. So let's go ahead and close this out. All right, so when we look at some posting samples, what I'm going to do is just turn the turning cycles on. Like I said, these are the standard turning cycles. This is Fanuc. Let me see here. Let's turn post, yes, no. Let's turn everything off. Turning cycles, let's turn them on and post. So we just have some standard turning cycles here, nothing too crazy. Just showing a little bit about the format of the code or what you can expect from the code. So that's pretty straightforward code as far as what we're looking at there. Let's turn the turning cycles off. Let's look at the face, mill, and drill. And then we'll post this up. All right, so this is the face milling and drilling. So you can see our G81 cycle here with our C-axis motion. Let's see, this is the face pocket. So you can see X and C in order to cut the pocket here. We get a lot of code on that one because it is an adaptive routine. Let's see, we got the spiral pocket going in there. This is the profile rough, so that's probably the profile finish, and here's the chamfer cycle as well. Okay, so you can see we're getting a lot of X and C type motion. Randy had a question, does this post as C-axis? I noticed the tools were moving around the part like they were in Y. Yes, it posts in C-axis like you can see in the code here. When you go to simulation, when I run it in machine simulation, you'll see the part spin. If I'm running it in tool orientation, you'll see the part spin. So it depends on how you're simulating will show what it's going to look like. So we'll go through that some more as we go. All right, so this is our face milling and drilling. All right, so let's go ahead and turn these off. Let's look at our wrapping group here. So we're going to turn this one on and post up this code. So this is what our wrapping group is looking at. So you can see we have Z and C motion. When you're using a wrapping group, the tool is going to be pointing center line. So we're going to see, again, none of these examples, we're going to see any Y-axis motion. The software does support Y-axis, you know, as a standard C and Y. But for this machine and this demo, it's all just C-axis. So when we want to cut the slots or these pockets around the OD, we're using a wrapping group, and you can see how that's using Z and C in order to position. Now we'll turn that off. Here we're going to go to an index system. Let's turn this one on. We'll go ahead and post this code. So here you're going to see it indexes to a position, you know, and then it's milling the slot, and then it indexes to a position, and then it mills the slot. So you can see how with the indexing you're going to just index and machine. Again, this is just showing different ways in which you can use the software and the ways the posted code will come out. We'll turn that one off. Let's turn this one on, post it up, and then this is again a drill routine here where we're going to drill, we index to those flats, and then we drill some of those holes, okay? So again, just some sample codes that you can look at. Now, again, there definitely can be different M codes that are called, and there can be different formatting. This is a generic Fanuc style, I believe is what I'm demonstrating. It's the BC1T1S machine with the BC1T1S post, and that does come standard with the software. When you install the software, it will be there. The post edits for the MillTurn is the same as it is for mill, or the same that it would be for turning, so you can open it up in a text file and make the changes as you go. All right, is there any questions before we get going with our sample here? Just go ahead and call them out. If there's no questions, we're going to go on and move to the next part. All right, it doesn't look like there's anything, so let's get started here. So what we're going to do, so this is the part that we're after. What we're going to do is open it up. I did draw this in SolidWorks, so what I'm going to do is just open up this file here, and bring it in from SolidWorks. Now, at this stage, really we're at the CAD preparation stage. You know, when you're dealing with CAD and CAM, one of the first steps is CAD preparation, and either you do it in process as you go, or you kind of get most of it done before you get started. All right, so from here, what I want to do is I'm going to turn my axis and part display on. All right, so this is my world coordinate system, and if you're familiar with BobCAD or really turning in general, you know, you have X and Z is going to be your quadrant that you use for laying out turning cycles. So that would be this cycle when we're dealing, or I'm sorry, this quadrant over here when we're dealing with the standard turning software. We do all our layouts in this quadrant. Now for me, when you're in MillTurn, you can actually set your origin wherever you want. So, you know, I could program it like this, and then, you know, this quadrant here would then become where my turning cycles are. So I've gotten into a habit, it's just, you know, a workflow that I've gotten into is I align the part with how the part would be orientated on the machine. And in this case, I just have it match how it would be with 2-axis turning. So there's a couple of things that I do here. One of the things that I'm going to do is just create a new layer and make that layer active, and then I'm going to extract wireframe for this this circle here. Okay, and the reason why I do this, number one, is I can come in here and measure it, so I can find out, you know, where it's located in X, Y, and Z. I can find out the radius, you know, so I can come in and inspect. The other thing I'm going to use this for is I'm just going to snap a point at the arc center, and I'm going to use that to drop the model down, so the front of the part, like this position, is now at Z0. Okay, so I'll use utilities, translate, select all, spacebar, sketch enter. I'm going to pick the start position and enter the end position, just like all our other translate functions work. So we'll drop that down and we'll hit cancel. All right, so that gets the part here. The next thing I'm going to do is I'm going to rotate it. But before I do that, I'm going to create some wireframe for the front pocket face here, okay? Because I'm going to need to do, like, I'm going to profile this. I'm going to chamfer it. So what I want to do is I want to generate some of the wireframe here while I'm here. So I'm just going to create a layer called, you know, pocket, or you can name it whatever you want. I'm going to extract some of the wireframe here. I'm going to project it to Z0. I'm just going to pick on this face right here. I'll hit my space bar, and what that does is it will give me the wireframe for that face. Okay, this one on the inside actually is on the inside of the chamfer. So what I'm going to do is I'm going to extract another one here. And again, you can drive toolpath off of surface edges. I really only need to do this one for the pocket because I want to do an open pocket, so I need an outside boundary, right? So what I'm going to do from here is I'm going to draw another radius here. This is just at the diameter of the part. All right, so we have that. I'm going to throw away this inside profile here. I'm going to throw away this chamfer here. Okay, I'm going to take this profile and I'm going to make it a dotted line. And this is my CAD prep that I would use for the face milling. I'm going to be able to do an open pocket from this outside here. I can do a spiral pocket here, and then I can work with the model for the whole location. So that's what we're looking at. So I've done my CAD prep. I'm not sure. Let me see if there's anything else. We have the part location. We did some measurements. We created the face pocket. The other thing we may need to do is like the OD profile of the part. So let's get the part orientated. So we're going to do a rotate here. Select all. Space bar. This is going to be what, 90 degrees in Y. We'll click OK. We'll hit cancel. Okay, so what that does is get us into this orientation. Now, what I want to do from here is I want to create the OD of the part. Now, the thing about the OD of the part is we have this hex, and then we also, you know, so there's like the shoulder here. So when we go to use things like section view, we don't actually get the full OD of the part, okay, because it doesn't intersect there. So we do have a tool that would allow you to spin the part and get the maximum and minimum OD, so we'll use spun profile. We'll select this. Now it's important to understand that the spun profile does return the OD of the part, but it does do some math and approximations. So when you zoom in here and we look at this radius is actually made into 3 sections, and that, yeah, 3 or 4 sections. So that actually, it has to do with the math that's involved to find the outside profile. So what I'm going to do here is I'm actually going to just redraw that radius because it's easier. I want to have a full radius there. I know what the size is because, you know, I drew it, but you would have a print normally. And what that does is just give me the OD of the part, again, using that spun profile and accounting for the hex. All right, so that kind of covers the CAD preparation that I may need to do on this part. I've generated some wireframe and everything else, okay? So the next thing that I'm going to do here, and again, if you guys have any questions as we go about that or any process, just go ahead and ask them as you go. All right. So from here, what we want to do is get our job going, okay? So we're going to go to our CAM defaults. We're going to do a new job, okay? This is going to be a MillTurn job, and then I'm going to choose my machine. Now, you can have us, when you get the MillTurn software, there's like a posting machine building process for the limits and rotations and all that stuff. So you will have a custom machine that comes with your purchase or as part of your purchase. Again, for today, I'm just working with the BC 1 turret, 1 spindle, okay? From here, I'm going to run the stock wizard, and actually I want to turn this one on here. So I'm going to run the stock wizard. Workpiece, it would be the part models that you would want to be the workpiece. So I'm going to go ahead. Randy had a question. Right now, the center line of the part is aligned with the x-axis. Should this be aligned with Z? It should, and you're right about that, but the way that I lay it out is like normal turning. So when I go through and I set this up, you're going to see how I'm going to align the coordinate system to the part. Okay, so again, we're skipping the workpiece. Those are models that would be past the simulation. We're going to do the stock type. It's going to be cylindrical. Okay, when we do cylindrical, we align that with our x-axis, which is the way that the part is laying down. So what I've done now is I've just aligned the stock to the part. Now, the end face, I mean, I don't know, I'll add some stock on the end of it. Doesn't really matter. On the start of the face, generally I'll add some stock on there as well because like you saw cut or whatever the case might be, you may want to take a couple of passes on the face. So you can show that by adding stock on the face, but I don't do that at this stage. At this stage, what I'm going to do is I'm going to align my 0 to the part. So right now you can see Z is going up and X is running down the center line, okay? If we turn our model off for a second, this needs to be X and this needs to be Z in order to use this turning as our profile, okay? So in order to accommodate for that, all we're going to do here is just align our origin, okay? So what I'm going to do is I'm going to click X-axis, and then I'm going to click on that point right there, and that aligns the X-axis, and then I'm going to click Y-axis, and then I'm going to click on this point right here, and that aligns the Y-axis. Now, like it flopped when we did that, so what I have to do here is flop the X, you know, and then flop the Y. Sometimes I can just pick those two and I don't have an issue with flopping. Sometimes I pick those two and, you know, it switches the side. I'm not positive of the rhyme or reason for it, but I know that I want my axis to be my Z, negative going back, and I know that this this point here is going to be my x-axis because that's where I have my OD part geometry laid up, okay? So hopefully that makes sense. And again, the orientation that I have the part in is by my choosing. You can have the part in any orientation, but your turning profiles need to be in the XZ plane, and your axis is the Z, okay? All right, sounds good. So we got that done. There are a couple of other things that I would generally look at in the setup. You know, if you have multiple spindles, you would say whether it was the left spindle or the right spindle. The other thing that we're going to talk about some more is this work offset and how we use this to push the part off the face of the chuck. So we'll get into that a bit more, but for this stage here, we can click OK, and what we do is we have our job set up, okay? So if we look at our part model here, we have our job set up. When we click on our machine setup, you'll notice that our origin shows up and it's in the proper orientation for the part, where we're aligning our Z and X profile for our turning. Okay, does that make sense, everybody? All right, so we got that there. Now, the next thing, so that's a little bit about your machine setup. Again, you know, that covers the basics of where you need to be. Z and X is for your turning profiles. You can have the part in any orientation. I just choose to align it with the normal turning, so when I'm in a top view, I'm looking down on the part just like I would be on the machine. All right, the next area that I want to get into is the tool crib, okay? So we're going to go to MillTurn Tools, and then we're going to go to the tool crib. Okay, so what's a little bit different about the MillTurn software versus the turning or milling software, the turning and milling software, there's a list of tools that you can use. In the MillTurn software, there's an actual turret, and it has each of the station numbers that are on that turret. You can import an STL of your turret, or there's a turret creator where you can tell it the number of stations. Again, because this is machine simulation, the closer you can get to the real thing, or the real proximity or dimensions of your turret, the better off you're going to be. Now, a couple of things here. It does take a little bit of time to set up your turret, just like it would out on the machine, okay? So the first thing I want to talk about here is load, okay? You do have the ability to load a turret that is already set up, and I do recommend, once you've taken the time to set up a turret, that you save that, whether you do it at the end of the job or whether you do it before even building the job, just matching the turret that's out there, or a standard configuration for your shop. Okay, so this way, before you really get into anything, you've already loaded up what's going to be on the machine or what you want to use. Okay, so that's the first thing that I wanted to talk about the turret. The second thing is, you know, when you have this open on the screen, you do get a rendering here. You can zoom in, you can zoom out, you can see exactly what's going on. So this way, you know what's happening. Okay, over here you have your turret. You have all your different stations. You can see the ones that have plus signs have adapters attached to them. Okay, so let's go ahead and cancel out of that. Let's go back to our tools, and let's go to our turret, and you can see we have nothing in here. Okay, so the first thing I want to talk about is stations. So we have station 1 through 12. There's 12 turrets on this machine. Okay, so you can click through, and if you want to add something to one of these, this is a right click, so I can go to station 1, right click, I can add an adapter, add a tool, unmount all, delete all. Okay, and you do have a couple of different sections here. So you have the stations, you have loose, and you have shelf. Okay, so the stations are what's going on at those stations. Loose is when you've called the tool through the machining wizard, like a profile or whatever it is that you're doing when you're generating toolpath, but that tool isn't mounted. So that is what a loose tool would be. A shelf tool would be when you unmount a tool that isn't being used in the job, it goes on the shelf. Okay, so just some organizational tools here, because you may need to change around locations, you may need to swap out tools, or reorganize the turret for clearance issues. So you can take items that are on a station, you can unmount it, and then it will put it on the shelf, and then you can then put it back onto a station. Okay, so let's get into, so you have a station here. When you right click, you can go to add adapter. There are adapters built into the software, some standard ones. You can go over any adapter and you can double click, and it will give you a display of the adapter. Now you can model your own adapters, you can download them. All of this stuff that's going on in here has to do with aligning the adapter so that it matches, so you can have it on the turret. If you're going to do, if you're going to model them or download them, it's best to bring them in and align them beforehand, and save them and then load them in, but there are a bunch of tools in here in order to align what those adapters are doing. You can go over any adapter and double click it, and this way you have a display of what that adapter is. So if you're unsure what that one's going to be, you can go to it and be able to tell what's going on. Okay. Now we do support adapters that have multiple tool locations, like in this one here. This is a dual Z, so you could machine on the first spindle and then also machine on the sub spindle. Okay, so or you could have multiple pods, which is actually a really cool feature. Not going to cover that in today's webinar, but that is a real big feature of the software. Now the other thing too, we have some side mounts here, so if you have some side mount adapters, there's a bunch of standard adapters that are built in here, okay? So you can go to any station, you can add an adapter. When you're looking through the adapters, the naming convention is pretty straightforward, but if you're not sure what it looks like, double click on it, it will come up and you can see what's going on, all right? So the next thing that we want to do here, so what I'm going to add an adapter. So I'm going to go to station number 1 and I'm going to say add an adapter, and I'm going to say a face mill adapter. And if you look at this adapter itself, you know, is not designed for that particular slot. We have some holes that are available, so we'd really want to put that an adapter in one of those stations. So we're going to go to this one and we're going to say delete, and that will remove it off of there, okay? We'll go to station number 2, right click, add adapter. We're going to do face mill adapter and choose OK. So here you can see we have a face mill adapter here, okay? Station 3 we're going to switch or skip. We'll go to station number 4, right click, add adapter. We're going to do a, what do we got here? This is a cross mill adapter, okay? So you can see this adapter is aligned parallel with Z, and this one is aligned perpendicular to Z, okay? So two different types. The reason why I cover these two is with Z-axis, if you're machining on the face, you'll use a face mill adapter. If you're machining on the OD, you'll use a cross mill adapter. Okay, next thing that we want to look at is adding a tool. So I'm going to right click on this adapter here. I'm going to go to add tool. I can go to my library, I can pick any tool and choose OK, and here you can see that tool is now mounted to that adapter. If I go to my cross mill adapter, right click, add tool, go down, pick any tool, click OK. Now you can see that tool is added to that adapter. The thing with this one is though, is the tool orientation isn't correct. You can see that it's still parallel with Z. So what we want to do is use our mounting orientation in order to change which way that tool's going. So we can change it from a 1 to a 2 to a 3 to a 4, depending on what you're doing with that tool. In this case, we're really just looking at 1s and 2s for this application. So you can see that one's now running perpendicular to Z, all right? So that covers a little bit about the face mill adapter, adding a tool, cross mill adapter, and adding a tool. The next thing that I want to talk about is I'm just going to show, I'm going to unmount this one, so I'll right click and go unmount, and what you'll see is that was added to the shelf, okay? So now I can take this one and I can say mount, and maybe this will go on station 11 and click OK. All right, so station 11 was the wrong one, so we're going to right click, we're going to go move to, and we're going to move it to station 12 and click OK. And you can see how if you go to an adapter and you go unmount, and then we go to this one and we go to unmount, they get put on the shelf, and then we can move them around. Okay, so that's just a little bit about the shelf, mounting and unmounting. All right. We also talked about moving as well, so you have the ability to move them around. Is there any questions about the tool crib at this point? No? Okay. The other thing I do want to talk about real quick, let me go to station number 1, add tool. We're going to go to a turning tool. I'm going to grab one up. You'll notice that with the turning tool, the tool orientation is right at the face of the turret, okay? From here, you'll use your shift values. These shift values are what you use to say how much hangout is going on. So, for instance, if we wanted it hanging out 3 inches away from the face of the turret, we could use a -3 here. And if you're not sure which axis you're adjusting, just look at the gnomon here, and that will help you. Okay. The other one here, this is going to be -1/4 inch. Nope. That's not what I wanted. Let's see here. This is going to be a 1/4 inch. Actually, this is just moving it up or down. I don't need to do that. The Z, I think this is the one that I was looking for. Yeah, minus 1/4 inch in Z to get it flush with the face of it. Okay, so you can use these shift values in order to change how much that tool is hanging out, you know, or how little it's hanging out. The importance of this, again, is for accuracy for machine simulation, so you see what's going on. Okay, you also, whether it's like a left-hand cutter, you can see the insert and where it's facing. You can swap whether it's a left-hand cutting or right-hand cutting just by using this swap. You can also adjust the tool orientation depending on which way the tool is going to be sticking out for how you're going to use that tool. Okay, so that's a little bit about the turning. A question came in, when you save the crib, does it save the tool in the shelf as well? You know, I didn't test that, Randy, so I'm not sure. I believe it does. But I'll have to get back to you on that one. I'm not positive whether it does or doesn't. Let's go ahead, let's just try. All right, so let's go here, load. It does save them, okay? So if they're on the shelf, it will save them as well. So that's good to know. Thanks for bringing that up. All right, so let's cancel out of this guy here. Let's go back into our crib. We're going to do load, and we're going to grab this one here, and then we'll choose OK. So I just pre-populated a bunch of the tools that I would want to use for this. OK, now let's get into our turning cycle again. Turning for the MillTurn is the same. Now I will reference this. You will notice it says UTMS, which is upper turret main spindle. We do use work groups when you're dealing with multi-spindles or multi-turrets, and that says which combination of spindle and turret is being programmed at that time. You can set that at the setup location, but you can also change it at the feature location as well. All right, so that's how you change what orientation. And again, I'm going to throw this one out here because I made this mistake too many times. The orientation of your turning geometry, regardless of whether you're using an upper turret or a lower turret, will still be in this orientation. I just wanted to throw that out there because I know I ran into that a bunch of times thinking I needed the geometry to be on the bottom in order to do a turning cycle because I was on the lower turret. That is not the case. All the turning profiles is in this same orientation, and then your machine group will tell you whether you're going to use that or not. And in our case, we have upper turret main spindle. That's all we have, so that's all we're going to use. All right. Now, I'm going to, again, we can come in here. When we get into our machine setup, you'll see both your milling routines, and then you're also going to see your turning routines as well. So we could do, turning cycle, lathe turning, select geometry. I'm not too concerned with the turning cycles here because, this works the same way it would work on the 2-axis lathe. You have your feature type, you have your constraints. I did an intro to lathe turning not too long ago, so if you haven't watched that, go ahead and watch that. I'm going to use the same tool for the rough and finish, so I'll go to my tool crib, station number 1. That's good. I'll go to my finish, go to my tool crib, station number 1. Okay, and then I'll just compute, and it will generate our turning routines. All right, so that's our turning routine. Again, we can go to that routine, we can choose backplot, and we can see what's going on. All right, we can go to simulation. If we go to simulation, what we're going to see is that the tool, the stock itself, when we're in machine simulation, you're going to see the face of the stock is right in the turret, okay? Because the 0 for that chuck is its face. That's how the machine was designed. And then what you use, like I talked about earlier, is you use that work offset in order to push the part out away from the face of the chuck. Okay, so if we go back into our machine setup here and we choose edit, we can go to work offset, and then here where it says C-axis, however much we want that sticking out, you know what I mean? So I'll make it 5 inches so it's exaggerated. We'll go to simulation again, and then what we're going to do is we're going to see that that stock now sticking 5 inches out off the face of the chuck. Okay, so so that's what we're looking at there. Again, we can play this through, and you can see that we roughed and finished off the face of the part there. That's fine. All right, now let's look at our milling cycles here. So what we're going to do is, so we have our turning routine. We're going to come in here, we're going to load our mill routine. The first thing we're going to do is just mill drill hole, okay? So we're going to go to mill drill hole. We're going to go to select geometry. I'm going to turn my CAD model back on, all right? And what I want to do here is just pick the holes that I want to work with. So I'm just picking these holes. You do, like, when you're trying to pick off the model, like, this is what the software is seeing. Sometimes it can be a little tough when you have a bunch of things that are in the background. If you hit W on your keyboard, you'll get the UV lines, and if you hit S on the keyboard, you'll turn the shading off. The other thing I generally do here is I'll do transparent. I find that transparent is also another T for transparent, an easy way to see when you have the holes selected. So I'll go ahead and select all the holes that I'm working with. Standard milling, ignore Z, that's fine. We'll just say okay. Here we're going to start our mill hole wizard. This works the same way as it does for the milling software. We can choose pick bottom. You know, we can come in and pick how deep that is. We can go next. From here, we can start programming how we're going to drill it, just like we normally would. For us, in this case, we're going to just go hole. We're going to remove the center drill. We're going to just do a drill cycle. When we go to the drill, we're going to go to our tool crib. It looks like it pre-called it for us, but we can go to our tool crib here. You know, we can see that we already have that drill loaded, and that's the one it's calling. So we'll say okay. Now you will see in posting you have auto, y-axis mode, longhand code. If your machine has a y-axis, you know, you can choose to use the Y or not use the Y. So right now it's set to auto, so it knows I don't have a y-axis, so it's just going to use my C on this. All right, so we have the tool set up. We're going to go ahead and compute. And that's it. It's gone ahead and programmed those holes. So we're going to right-click on our operation here and choose backplot. And from here we can step through and you can see where it's going. Now again, a lot of people are saying when in the backplot, wouldn't it be nice to be able to see the part spin? If we want to see the part spin, we just go to simulation, and we're able to see it spin in the chuck. Now generally what I recommend for a visual check, just run it through the backplot. That's real quick and fast to load up. When you get into here, we can do next stop. Next stop for the finish. We can step through and we can see the turret comes down to location. You know, here we'll slow it down a little bit. We'll go turn off our tool path, and you can see how it spins and it's drilling those holes. Okay, so there we have a little bit of face drilling. You know, any of your drill cycles, you could have spotted first or whatever you needed to do. You could see that that was really pretty painless to come in there and to drill those holes. Now, when we look at you know, the pocket here, right? What I'm going to do is I'm just going to turn the model off, and I'm going to go to this geometry for a second, and then I'll go to a right view. So this way I can just look at it square on. I'm going to blank out my turning routine. So we went ahead and drilled our holes. Now let's look at doing our pocketing. So we're going to right click, mill feature, 2-axis, select geometry. We'll select this face and this one here. We can pick our depth up off of the model. So we could say pick bottom, bring the model back up, grab the depth, okay? Next, we can set what type of routine. So we're going to do a pocket, profile, finish, and we're going to do a chamfer. Actually, I'm going to do the chamfer routine separately because I want to, but I want to break the edge on the pocket wall and the circle at the same time. And sometimes I find it's easier when you just separate them. But again, that's up to you. So we got our 1/4 inch tool here. We have a 1/2 inch tool here. So, what I'm going to do is go to my tool crib. Let's see, there's some loose tools that came in. This 1/2 inch tool doesn't exist. If we go up here, we have a 3/8 end mill, so that's the one that I'm going to want to use for the rough of the pocket. For the finish wall, I'm going to go tool crib, and I'm just going to use the same tool. You could set up separate tools, but I'm just going to use the same one. Nope, this is the cross mill. Let me go to the face mill. I'm grabbing the wrong tool here. So this one, let me check. This one needs to be the face mill as well. Okay. All right, so we got that one. We got this one. We're going to go ahead and look at our pocket routine. We're going to do an advanced pocket with adaptive, so that way it will work its way in from the outside. The profile, we're going to come in here. We're just going to do a standard profile, do a circular lead in, and we'll finish. Okay, so we got the pocket set up just like we would normally have a pocket set up. I'll go to my default chain start point, modify. I can change where this is going to lead in from for the finish pass. I'll hit my space bar to lock in my directions. We'll compute our open pocket, and then it's just going to work its way in from the outside. And then from there, we're going to compute on our finish, and then it will just finish that profile. Okay, so does that make sense, everybody? Any questions about that? All right, so that gives us our face mill for our open pocket, and then also gives us our profile. And again, if we want to come in here and do like another feature, we could like copy this feature, paste this feature. I can use the same depth value. So now I have 2 of these. This one I'm just going to select the circle here. If I computed, I would get the same settings, but what I want to do is I want to go, let's see here. Let's make this a circular pocket instead. Come in and check my direction to cut. Looks good. We can compute our circular pocket or a spiral pocket. So that, again, is just going to spiral in and cut that. And then we have our profile here, which we might want to adjust our lead in there, but that will come in and finish that wall. Okay, so once we have that feature done, we could copy and paste it, use the tools and everything else in another location. All right, if we want to come in and do the chamfer, again, we'll just mill feature, 2-axis, select geometry. We can select this one and this one, space bar, next. Machining strategy, we're going to do a chamfer. Next, go to our tool. We already have a chamfer in here. We can check our tool crib. So the space mill, we got our 360, so that's good. Come through, set what our leads are. All right, set our depth when we get in here. We have what our depth is. All right, finish. We can look at our start points if we want them to go in different positions or start where we want them to start them, and that's our chamfering on the face. Okay, now we can go to simulation. This will load it up. Now there's a couple of things you can do to get this where it needs to be. You can just go next stop, next stop. You can also pull up, you could do the move list here, and what this will do is show you all your operations, so then you can jump through to which operation you want to look at. Okay, I generally just use next stop to kind of see where it goes from there. We can run this. So this is the face pocket. So we see what's going on. All right, if you guys have any questions about face milling and drilling, go ahead and ask that now. Otherwise, we're going to move on to the OD milling and drilling. All right. Looks pretty good. We get our chamfer there. We get our chamfer there. All set. Okay. Now, like I talked about before, I'll talk about the groups here real quick. So you know, if you right-click on your machine setup, go to additional functions, and then you can do add group. If you're in a group, you can't add any toolpaths in that group, okay? What you need to do is drop a toolpath feature in there. So this one will say, all right, so this one will just drop that in there. So now we have the turning cycle. And then once you have a turning or a feature within the folder or the group, you can right click and then you can add more in there. Okay, so that's just a little workflow there. So we have our turning cycle. We'll come back up to the top here, add group, rename. This is face mill. And then we can come in here and drop these features into the tree here. Okay, so then again we can blank that one out and blank this one out so we're not looking at it. Okay, so from here we're going to pull our CAD model back up. So what do we want to do here? Well, one of the things that we want to do is these slots, you know, these kind of, I mean, I guess it could be a pocket. I'm going to do it as a profile. So we have these slots along the OD here. We have these like shoulders or these slots here, and then we have to drill the hole. So the first one I'm going to do is going to be the wrapping group, and the wrapping group we're going to do on the OD. So we're going to go right click, additional functions, and then we're going to go add wrapping group. Okay, so now we have a wrapping group. From here we're going to edit the wrapping group, and then we're going to use the stock diameter, or we could enter in the diameter that we want to wrap to. We're going to use wrap geometry, and then we're going to click OK. So that's all we need to do there. Okay, the next thing we're going to do is right-click and load in our routine. We're going to select our geometry. Now, a lot of times for like 2D change, you can right-click and choose constant Z. Here, you know, if I try to choose constant Z, I'm not going to get it because there isn't a constant Z. If I right-click and I choose loop, that will give you an option to get it all the way around. You'll notice that there's two different chains I can pick. I can pick this one, which would give me that one, or I can pick this one, which would give me the one that I'm after. So I'm going to pick the outside one, and that will give me the one that I'm after, and then I can choose spacebar to lock it in. If I do select geometry again, if I clear this, if we look on the other side here, you can see that there's a break in this bottom edge. I'm going to go like, and you can see there's like a little break there as well. Let's see if it works on that one. We're going to right click, choose loop. Okay, when we choose this one, it looks a little crazy. I don't know. It doesn't quite give us the option because there's this break here. So you just need to be aware of that when you're choosing your loops. You know, if your loop isn't able to go all the way through, you can just click through and pick the edges that you want to work with. And that's what I'm doing here, is just picking the edges. We don't pick the vertical walls, we pick the edges that we want to work with, and spacebar, that locks that in. So we have that one there. This one, we can do the loop selection, and then that will grab that one there, spacebar. Next. All right, pick bottom. You can pick on the bottom. It will pick up the bottom. You know, we're going to do a profile routine. Okay, from here, we can check our tool crib. Let's see, cross mill, 1/4 inch, that looks good. We'll say okay, and then you're in a standard milling routine, so you can answer all the questions just like you normally would, and then compute, and then there you're going to see that we're able to mill these two slots along the OD. No big deal there. So that's a wrapping group on your MillTurn. Now, the next thing we're going to talk about is these slots in here. In order to do these slots in here, yeah, I mean, well, I'm trying to figure it because I have a slot and a drill, and then I have a drill along here as well. Both of these I'm going to use indexing for. So what I'm going to do is add an additional function, add index. Okay. Right click on the index, reselect. From here, I'm going to pick a surface or a UCS. You could create a UCS as part of your CAD prep. I didn't do that in this example, so I'm just going to pick a surface, click OK, pick on this surface, spacebar. So that gives me one index system to index to this location. I'm going to right-click, additional functions, add index, right-click, reselect, pick a surface, click OK, and then I'm going to pick on this surface here, and that gives me another index location. So I have two different index locations. Okay, you'll notice that there are multiple copies. There's 3 of these. So I could go around and index each one if I wanted to, but I'd rather use a toolpath pattern for that. It's just quicker and easier to get there. So what I'm going to do is right-click. This is Mill to Axis, select geometry. I'm going to choose, let's see, constant Z gets it all the way around, but then I'll just unclick that one there, and that's fine. Spacebar, next, pick bottom, pick the edge, okay, next. This is going to be just a profile. I don't remember the width of the slot, but let's see here. There's a 1/4 inch. Let's see if that one works. We'll click OK. Leads, we'll just have it parallel a little bit. Compute. Okay, so this one wouldn't work. The reason why the tool is too small, the reason why is we would be able to get a Y move here. See how what it's going to do is end up moving over, and we can only machine this without our Y. Okay, so what we got to do is change our tool here. So I'm going to just come back into it, go to my rough tool crib, and then I should have, let's see, this one's a 3/8 and compute. Okay, so this one, when I switch to this one, I'm getting no toolpath, but because it's a rough routine, there's stock for finish. There's probably 15. So I need to clear that because there's no room for the tool otherwise. So if you're doing like a slot like this, you have to make sure the tool you're using is the width of the slot. And then also on my lead out here, let's go vertical and compute. All right, there we go. So this one's going to come over, come down, come back out, and then there we go. So that gives me my slot there. Now, if I want to create copies of this all the way around, okay, what I'm going to do here is I'm going to add a pattern for it, right? So I can right-click on this, additional functions, add toolpath pattern. Now, one of the things that kind of becomes a stumbling block here, we'll do a rotate. Okay, we need to do a 3D option, and we need to pick an axis of location or rotational axis. Now, you would think you could just enter in the values, but you have to look at it in relation to the machine setup. So what I'm going to do is I'm just going to click OK here. And one of the steps that I forgot to do was to draw a center line. So I'm just going to draw a center line here. Okay, and by drawing that center line, it gives me the ability to set what the axis of rotation is. Okay, so we'll come in here. We're going to edit this. This is going to be pick start. So we'll shift click to grab the endpoint there. It's going to be pick end. Shift click to grab the endpoint here, and then that picks up the axis of location or rotation. We can set what our angle around is, how many copies, choose OK. So now we're able to cut these other slots that are in our model without having to go through and pick them. We can do the same thing with our drilling routine as well. Okay. When we look at the next index system here, we're going to just right click, drill hole. We'll come through and select this cylinder here. We'll click OK. We can pick the bottom. We can enter the bottom. We'll next through this. We'll go through our strategy. We're going to just drop our spot, and then we'll pick up our tool here. Should be set up for us. Let's see. All right, so this one we don't have set up. So what I'm not going to use a drill. I have an end mill here, so I'm just going to use this end mill. We'll choose OK. We'll go ahead and compute. You can see that one is being programmed as well. We're going to use the same process. We'll use the toolpath pattern. So we'll add in from the index system, we'll add in the pattern. We'll do an array, or I'm sorry, not an array. We're going to do a rotate, 3D option. This is 120, 2 copies, and then pick our rotation axis. And then OK, and then you can see we're able to drill those as well. So I'll run this through a simulation here and take a look at what we got. All right, here you can see I have some sorting issues as far as the order in which it's cutting things, right? So we're going to go ahead and pause that. We're going to go back to our CAM tree, and then we're going to make an adjustment to the order in which things are done. So we'll right-click on the MillTurn job and go to the machining order. We're going to run it in the order that the features are in, which it will go through feature by feature and run it in that order. For some reason, this chamfer mill is coming up beforehand, but what probably happened is when I dropped them into the folder, which is what I did here. When I went into this routine, I just dropped them in there, and you can see that the chamfer mill is first. So that's what's happening there. What I want to do is I want to bring that down in the tree. Okay, so we can move this one up, and you can see that one went down. Now I can either do it in the tree, or the other thing I could do is just go to the machining order, and we can take this chamfer mill and we can drop that down as well. We can say go below there, and we can say bring this drill up in the order as well. So you can either do it in the tree, or you can do it in the machining order dialog. Okay, so we got that set up, and that's a good thing to realize. Like when you're dropping those operations in that group or that folder, the order that you're dropping them in there, depending on what your machining order is going to have an effect on it. So we're right at the 2 o'clock mark here. I've gotten through the things that I really wanted to get through, which I was surprised I was able to do it. I know I went kind of quick. Are there any other questions that you guys have about MillTurn at this time? I know Randy was pretty active with a lot of questions. Randy, do you feel that, I know you said you had some training recently, you know, if you have any comments about this webinar and how you feel about it, or the topics that I covered, please let me know. Anybody else, if there are any other questions that you guys have, you know, Albert, if you have any questions, or Anthony, now's the time to ask them, because we are right at that 2 o'clock mark, and you know, we're getting ready to wrap up here. Again, I want to thank everybody for I want to thank everybody for taking a moment to come out. Yeah, Randy, if you look, when I went to simulate it at first, I had reordered it, the machining order, because of how I dropped the features into the group. Now that I went through and adjusted the machining order, I started to do it by the order of the features in the group, but then I went in and adjusted it in the machining order through the CAM tree, and you can see now it's cutting in the order that I wanted it to. So hopefully that was good. Randy, if you're doing a back plot in the CAD interface, it doesn't show the toolpath pattern. If you are doing a simulation, it will show the toolpath pattern. It's just a little bit different the way that it shows up. So back plotting in the CAD interface, you won't see the toolpath pattern. You know, again, this is an intro to C-axis programming with the BobCAD version 29. 29 software. You know, I definitely will end up, I mean, there's part transfers. I didn't get into the MDI programming block. I mean, there's a lot of different features that are still here to cover, but I did want to go ahead and show you guys what you're looking at here with the MillTurn package. Again, if there's any questions that you guys have before, any other questions that you may have about the MillTurn software, you know, please let me know. Now would be the time to ask. Otherwise, we're going to get ready to wrap up here. Okay, so thank you again for everybody spending some time with us here today. Yeah, Randy, I know I hadn't experienced any issues with that, so I'm not sure why that had come up. There are some other things that I ran with the cylindrical stock being off center, but that was some user input in order to adjust that. Jesus, thank you again. Thank you for attending here today. I really enjoy this stuff. You know, if you guys aren't MillTurn customers, it is the day after 4th of July. You should have gotten an email on some promotions that we're running. I know that there's some really cool things that you guys are doing. Again, I appreciate everybody taking a moment. If you haven't asked a question while in today's webinar, before you leave, please ask at least one question. Any question. You can ask me, you know, what kind of ice cream I like, or you could ask whatever you feel like asking, but please ask some questions about the MillTurn software before you leave, if you don't mind. Move your cursor to define the Z-axis. Can you elaborate on that, Chuck, as far as what you're looking for that? Yep. Any other questions before you guys go? Again, it's been a pleasure working with you here today. Really enjoyed these webinars. This was a fun one to put together. Hopefully you guys found it informative and useful. Again, if there's any other questions, go ahead and ask it now. Otherwise, we're gonna sign off for today. Thank you so much.